In this video, we're going to be learning how to add, subtract, and multiply complex numbers. So for all 8 of these examples, we're just going to be simplifying each expression until it looks like one complex number. So right now we have 2, and basically when you add complex numbers, you're just going to be adding the real part with the real part, and the imaginary part with the imaginary part. So if I do 4 plus -4, well, that gives me 0. And if I do -3i plus +3i, well, that just gives me 0i. So altogether, that is just 0. Now, a very interesting first example is the fact that we got 0 makes these additive inverses. It's kind of like having +4 and -4, but also the imaginary parts are opposite too. So when we combine them, they just cancel each other out. Now, I'm going to go down here to the example below it. So here, I don't have the i's yet. In fact, I have the square root of -9 and the square root of -49, which I already know right now that these are going to be imaginary numbers because there's a negative underneath the radical. So my first step for this problem is actually going to be to simplify those radicals. So the square root of -9, the square root of a -1 gives me I, and the square root of 9 is 3. So I get, now instead of 4 plus square root of -9, I have 4 plus 3i. And on the right here, I'll get 6 minus, again, this minus doesn't cancel out that negative because one's inside the radical and one isn't. But that negative on the inside gives me an I, and the square root of the 49 gives me 7. So now once I'm here, I'm going to combine my real part with my real part and my imaginary part with my imaginary part. So 4 plus 6 is 10. And 3i plus -7i is -4i. So when I combine them, it's just like combining like terms. We get 10 minus 4i. Now let's look at the next example. We subtract, which is basically the same as adding. We just now add the opposite value. So we're going to subtract our real parts and subtract our imaginary parts. So real part, 5 minus -2. Let me fix that. Make sure that's a red underline. 5 minus -2 would be a 5 plus 2, which would give me 7. And then -3i minus -4i would be a -7i. So altogether, that is just 7 minus 7i. And that is the complex number I get when I subtract those two. So oftentimes when you add or subtract complex numbers, you still end up with a complex number, or sometimes it becomes real and the imaginary parts cancel. But it's all about combining those like terms. So for our next one, we have those square roots again. So I need to rewrite this as 10 plus the square root of -9, which will be imaginary, the square root of 9 being 3. So I get 10 plus 3i. And the reason why we want to do this is sometimes we can get some mistakes that happen whenever we keep them underneath the radical as we simplify. So immediately pointing out that they are imaginary numbers will avoid those mistakes. And also here we can also combine those two numbers together once they're simplified. So over here we have 2 plus -25, square root of -25, which again, it's going to be imaginary because of that negative, and the square root of 25 is 5. So now we'll combine our real parts with the real parts and our imaginary parts with the imaginary parts. So 10 minus 2 is 8, and 3i minus 5i is -2i. So for our final answer, we get 8 minus 2i. Now when we're multiplying, we have to be very careful because in this instance, it's not like combining like terms. We now have two binomials being multiplied. So in order to multiply two complex numbers, we need to either distribute or use the FOIL method, meaning 4 plus 3i is going to be distributed to the -1. So -1 times 4 plus 3i and to the negative 2i, so we get negative 2i times 4 plus 3i. And then we distribute, giving us negative 4 minus 3i minus 8i, and then negative 2i times 3i will give me negative 6, but not I times I, which is I squared. So now as I go to simplify, I need to remember what I squared is equal to. And it's equal to negative 1, a real number. So whenever I see I squared, I need to reduce it to negative 1. So now I have negative 4 minus 3i minus 8i minus 6 times negative 1. So I have negative 4 minus 3i minus 8i plus 6. And now I have all these terms just like over here that I just need to combine my like terms, starting with my real part first. So negative 4 plus 6 gives me 2. And negative 3i minus 8i gives me negative 11i. So when I multiply these two together, I get 2 minus 11i. Now, if you weren't careful, you might have put negative 4 minus 6i if you only multiply the real and then the imaginary part. So you have to be careful. You need to distribute. And again, the same rules apply. If I had square roots in there, then I need to get rid of those square roots first. So this becomes 3 plus, this is square root of negative 4, so the negative gives me an I. Square root of 4 is 2. And over here we have 4 plus just the square root of negative 1, which is just I. And then I'm going to distribute. So I'll have 4 times 3 plus 2i plus I times 3 plus 2i. Then I'll finish my distribution. So 12 plus 8i plus 3i plus 2i squared. And again, I squared is negative 1, so this is actually 12 plus 8i plus 3i, but instead of plus 2i squared, it's actually minus 2, because that's 2 times negative 1. Now combining my real parts and my imaginary parts, I get 10 plus 11i. So again, this answer is just one number, 10 plus 11i. It just has a real part and an imaginary part. Now let's look at this next one. We have negative 4 plus 5i and negative 4 minus 5i. These are conjugates since I'm just changing that middle sign. But if I were to go through and multiply, I would get negative 4, that negative 4 times negative 4 plus 5i, and then minus 5i times negative 4 plus 5i. Again, just distributing that left binomial. That gives me negative 4 times negative 4, which is positive 16. Negative 4 times 5i is negative 20i. Negative 5i times negative 4 is plus 20i. And then negative 5i times 5i is negative 25i squared. So a few things happen here. These were conjugates, so the fact that these middle terms are going to cancel is no surprise. But I'll now have 16. And over here, negative 25 times negative 1. So plus 25. And these will combine to give me 41, which is a real number. So here, they weren't opposites, these additive inverses. They were just conjugates. And conjugates multiply to give me a real number, which is really interesting, because we can actually use that in a later lesson to help us get rid of an imaginary part of a number by using its conjugate. Now lastly, we have an expression, but we need to simplify it because it wants us to add, but we need to distribute and simplify first. So if I distribute the negative 5, I get negative 5 minus 10i, and then 3i multiplied in gives me 9i minus 12i squared. So again, I have that I squared again. That's equal to negative 1. So I have negative 5 minus 10i plus 9i is now plus 12, because that I squared times negative 12 gives me a positive 12. Again, combine your real parts first, so 7. And then negative 10i plus 9i is negative 1i, give me 7 minus I. And by the way, me putting the real part first is just the proper way to write complex numbers. You always write your real part and then your imaginary part. And that is how you add, subtract, and multiply complex numbers.